Alright, so we have proof and perpendicular lines today, and we're starting off with a warm-up question here on the law of detachment and the law of syllogism. And we've had that a few times. So it says use the true statements. These are gibberish. These are not real words, but we still can follow the pattern of the rules, of the laws, and we should be able to get the answers that we need. So remember, the law of detachment means that something is detached. Like if I take this highlighter and I detach the lid, now it's broken into pieces. So detachment refers to things that are broken off. And when we are looking at that, we're looking for one of those detached things at the beginning. So the question is, at the beginning. So is West's loft at the beginning of anything? No. What about quasi-zerk? Yeah, that is right here. So that's at the beginning of this. So when we have a detached thing at the beginning, the answer is the end. So that's it. So whether it's words or gibberish or Spanish or French or English, doesn't matter. It still follows that same pattern. Something that doesn't have an if and a then at the beginning, and the answer is the end. Okay, now syllogism. Syllogism is like the transitive property. Okay, like the transitive property. Like the transitive. Okay, so the transitive property. So we're looking for something that's the same. So we're looking for the same, or I could have put begin equals end. Begin equals end is what I'm looking for. That's what we're all looking for here. Okay, so I'm going to just start here. Is that at the end? Well, not this, but is that the end of any of these? There it is, right there. So that was quick. So there's the beginning and there's the end. That's the same. And so when they're the same, we remove them, and the answer is actually what's left. So if and there we go. So we've done that in French and Spanish, in symbols, in made-up words, in English. So hopefully you get the hang of that. Okay, so there's our line. Our lesson starts here. So theorem 3.1. If two lines intersect to form a linear pair of congruent angles, okay, so I'm going to draw a picture to represent this. If two lines intersect to form a linear pair of angles, then the linear pair of congruent angles. So if we have this, and what they're saying is these are congruent. So we have a linear pair, two angles that share a side, and their other sides are opposite rays, and that's a linear pair. It adds up to 180. If it adds up to 180 and these two are equal, then that means each one has to be 90. And so what that means actually is that if those angles are 90, then that means that these lines would have to be perpendicular, all right? Which means that they form a right angle. Okay? If two sides of two adjacent acute angles are perpendicular, all right, so two sides are perpendicular of adjacent angles. So adjacent angles share a side. So it's saying, so here are my adjacent angles, and it's saying that's perpendicular. That's perpendicular. Then that means measure angle 1 plus measure angle 2 is going to be 90 degrees. If you have this situation, then you're going to have that. If two lines are perpendicular and they intersect, okay, if two lines are perpendicular, so if we have that situation, then it's not a very good arrowhead right there. All right, then all four of the angles are right angles. All right, so there's three theorems for us, and we've broken those down. So let's look down here. We have a proof. And we talked about how we can just keep trying to prepare for proofs, just keep working on it, fill in certain things. So you guys should be able to pause. Again, I forgot to say pause at the beginning of the notes, but that should have been a situation where you could have paused and hopefully done the whole thing there. So this proof, you should be able to pause this and fill in 3 of those right now. So go ahead and do that if you haven't done it yet. So prove, I'm going to do that in purple. Given, do that pink and red. So our first reason is pretty much given, always. Our last statement is what we're trying to prove. And our first statement is something that is given. So when we're doing a proof, we like to see, is there something else this tells us? Well, not really. So now we're going to have to kind of look at the situation and decide what we want to do. So a couple things we have here. We are given that AB was equal to CD. So that was given. We had some other proofs where we switched from an equal sign to a congruent sign. That's not happening here. It's all equals. So just things to look for. We're doing something like that. AC is up there, and BD is down here. Okay? So we have AB and CD. Now if you look, they both have this middle section of BC. So what we could do is we could say that if we take AB and we add BC to it, and if we take CD and add BC to it, normally we add it on the same side, like something like that. Okay. So that's a length. BC, when we say BC, that's a number. That's the distance between B and C. So when we take an equation and we add the same thing to both sides, why are we allowed to do that? The addition property of equality is why we're allowed to do that. Okay? Now this is one of those rare cases where the steps don't all, like this step tells us, the next step tells us. This is a little bit of a stranger proof in that we're kind of coming up with some of this stuff. So the next connection we want to make is we want to be able to say that AB plus BC equals that whole segment. So we're going to say AB plus BC equals AC, and we're going to say that BC plus CD equals BD. All right? Now, hopefully, when you look up here, you can say, hold on a second, that is the same as this. So we can take this out, and we can replace it with this. And similarly over here, we can take this out, because it's the same as this. It's just symmetric. It's just these two are switched, but that's still the same. And this can be taken out and replaced with this. Okay, so we're putting that in here, and we're putting this on this whole side. Okay, so, we never said what this is. So here I said that this smaller segment plus this smaller segment is equal to this bigger segment. So when we say that a segment is made up of two smaller pieces, that's the segment addition postulate. Okay? And finally, we're talking about here, taking this out, putting this in. That's going to be the substitution property of equality. Now, make sure you don't just write SUB, because that could be subtraction. So SUB is not a good it's not a good abbreviation for subtraction or substitution, because we wouldn't necessarily know which one we were talking about. Okay. So we're going to do one more proof, and then we're going to do some review. So here we filled in the things for you. Now, to save ourselves a little bit of time. Now, we have a proof, the given's here, that's what we're trying to prove. So a lot of times in a proof, the statement tells you what to do for the next reason and the next statement. So if you think about the definition of perpendicular, if BA is perpendicular to BC, then that means that angle ABC is a right angle. Now, how would I know that this is a right angle? Because that's the definition of perpendicular. Definition perpendicular. The definition of perpendicular is two lines or two rays or two segments, two things that form a right angle. So when they tell us that that's perpendicular, that definition tells us that that's a right angle. Now, again, so that statement led directly to this statement, and it gave us that reason. Well, similarly, this statement is going to give us our next statement and our next reason. So here, if we know that angle ABC is a right angle, then we know the measure of angle ABC equals 90 degrees. Now, how do I know that the measure angle of ABC is 90 degrees? Because that's the definition of a right angle. So you can see that sometimes we just have the definition of the thing that was said right before. Definition of a right angle. Now, we're trying to prove that these are complementary. Complementary says that two angles, two adjacent, two angles, they don't have to be adjacent, they are here, two angles that add up to 90 degrees. So what I could do now is I could say that the measure of angle 1 plus the measure of angle 2 equals the measure of angle ABC. Now, this is kind of, it's like you take a pause right here and you think of a new idea. So I know I'm trying to do complementary. I know I need to add the angles together. So that's the angle addition postulate that says that if you add two angles together next to each other, two adjacent angles, it adds up to the whole angle. All right. So now we can do something here. So hopefully you see what that is. Measure angle 1 plus measure angle 2 equals, I'm going to put those two together, and that's going to be 90 degrees. Now, we talked a little bit about the difference between the transitive property and substitution. So the transitive property, we say that A equals B and B equals C, so A equals C. Here we have more stuff. So we're substituting this one thing in place of that thing, and we have two things over here. So it's not the transitive property, it's the substitution subs property of equality. And finally, this is the definition of complementary. Definitions are biconditional. Definitions are biconditional. And the last thing about that lesson is that there's kind of three main types of proofs. The one that we're going to use almost exclusively on tests is the two-column proof. That's what we've been showing you in class. Statements and reasons, 2 columns, given, prove. All right, so nice little lesson today. That was the lesson's over. Now we're going to review. So on page 794, they review graphing lines. These are optional. You do not have to do these problems. So the two that we want to talk about today are standard form and horizontal and vertical. Or vertical and horizontal, we'll talk about in a minute which is which. Okay, so one thing we want to keep in mind is that slope uses the letter M, and slope is the rise over the run, and the way we do that mathematically is the change in y. How much does y change divided by how much does x change? That's the Greek letter delta. If you go to Greece, you'll see that letter on some signs. Greek letter delta. All right. And in science, delta stands for change. So that's the change in y divided by the change in x. Now, first of all, what we would like to do here is we want to be in standard form, we want integer coefficients. So we don't want that fraction there, so to make it easier, we're going to multiply this whole thing times 3. So that's going to be, and actually, since those are all negative, I'm actually going to multiply by negative 3. So the negative times the negative is going to cancel out. 3 over 3 will cancel out. That's just going to leave us with 2x. Here, it's going to be plus 6y, and down there, it's going to be equals 6. All right? Now, excuse me, sorry. If we divide this whole thing by 2, or multiply this whole thing by 1/2, x plus 3y equals 3. So why did we do that? Because I wanted to make the numbers smaller. So when you're in standard form, what we want are an x and a y intercept. So we have different equations of lines. We want to use the one that works the best for the situation that we're in. So most teachers just solve for y all the time. And that's great sometimes, but sometimes there's a better way to do it. So what we want to do here is find the x-intercept. The x-intercept means when it crosses the x-axis. That happens when y equals 0. Okay, and then we're going to want to find the y-intercept, which hopefully, clearly, it would be when x equals 0. All right, so if we let x equal 0 right here, I don't know why I'm doing the y-intercept first, and divide by 3, then y equals 1. So 0, 1. Now, this one, if we let y equal 0, then x equals 3. So that's right here. Okay? So now, I prefer to have more points on the line to graph it. So what we want to recognize here is what's that slope? Now you should be able to tell it from the picture. You also get it from the equation if you solve for y. But that's going to be down 1. The change in y is negative 1, and the change in x is 3. So negative 1 over 3 would be the slope. All right. This, y equals 2. Think about what that means. Y equals 2. Well, when does y equal 2? Well, let's plot some points. At 0, 2. At 3, 2. At 1, 2. At negative 2, 2. it doesn't matter. There's no x in the equation. It doesn't matter. So we get a line that goes straight across like that. Again, these are review down here, so you hopefully could pause the video and do those yourself. Okay. So that's the line y equals 2. That's what happens when y always equals negative 2. Now, we have x equals negative 4. That's going to be over here. And there weren't really any questions about that. I guess we could talk about the slope a little bit. So if we took 2 points off of here, remember the formula for slope is y minus y over x minus x. But y, 2 minus 2, that's going to be 0, which is undefined, which, oh no, just kidding. 0 divided by, I didn't put the x's in here, sorry. So the x's, pick any 2 points. So let's say 3 and 1. So 3, 2, and 1, 2. So 3 and 1, that's 2. So 0 divided by 2, actually, that's 0. The way I tell my students is if you take 0 divided by any number, we'll use k for the variable, that's okay. 0 divided by a number is okay. It's actually 0. Okay? Now, if we do this, we pick a couple points. I'm going to use negative 4, 0 and negative 4, 5. So the numerator is the difference of the y coordinates. So 5 minus 0. Excuse me. Sorry. X minus x. So we're going to get 5 over 0, which is undefined. So if you think about that, if you have a horizontal line, your coordinates here, your x coordinates are going to cancel out. You're going to be dividing by 0. So if you think about it, any number you get for the change in y, that was the change in y. If you divide that by 0, that's going to be undefined. But then if you look at that, any number divided by 0, no, don't do that. Don't divide by 0. Okay? All right, so now we have a review of factoring. Again, pausing this as much as you can to do these yourself. So the way we've taught is you take the reciprocal of that, and then you put the same thing down twice. This is positive. That means these both have to have the same sign, but this is negative. That means they both need to be negative. Now, a times c is 42. So you need the factors of 42 to plug in there to get what you need. So hopefully most of us can see it's going to be 6 and 7 because they're both negative, and negative 6 minus 7 is negative 13. Alright. Now here you can factor out a 2 and cancel out that half. So if you factor out a 2, you get that, and that's what's left. Alright, pause that, try it again. Hopefully you don't have to look over there. Alright, that's negative. That means one of these needs to be positive and one of them needs to be negative. I forgot to, okay, so the last is multiply a times c. Don't forget to multiply a times c. So that's going to be negative 90. So I need the factors of negative 90 who, when added together, equal 1, negative 1. So that's going to be 9 and 10. Now if you don't find them right away, you can start listing number 3 and 30. You can list different combinations of factors and keep trying it. So 9 and 10, it's negative, so that's going to be 10, that's going to be 9. So you can divide a 3 out of here. So if you divide those both by 3 and you divide these both by 2, you get that. midpoint. So the midpoint formula is the average of the x's and the average of the y's. So if I add the two x's together, get that. And if I add the two y's together, we get that, hopefully. Now, this is called a complex fraction. I think we've probably seen this before, but so for a complex fraction, you want to clear the denominator. Now, if you want, you could put these all over 1. It's not real official, but so comparing those 4, 1, and 1, you got to multiply by 4 over 4 to rationalize that. So that's going to be excuse me. Here the 4's cancel, and we just have 3. So that's going to be 3 plus 8 over 8. Now this one's a little trickier. You have 6 and 8. So a common denominator between those, 6 does not go into 8. If you double this, you get 16. 6 does not go into 16, but if you triple it, 24, both those go into 24. So multiply that by 24 and this by 24. This times this, 1/6 of 24 is 18. This (24 over 6) is 4. I started to do that a different way. That's not, I don't like that. Alright, so distribute here, 24 over 6 is 4. And here, 24 over 8 is 3, times that is going to be negative 15. And down here, that's going to be 48. So we're almost done. That's going to be 11 over 8. We don't have to do anything to that. This is going to be negative 9. Just kidding. Negative 11. 15 minus 4. All right, there we go.